We've done our signs and symptoms of people exposed to the chemical. Now it's time to move on to the next step, which is the initial recce. We're actually putting guys in suits and sending them in. And they've really got a couple of jobs. One is to be the eyes and ears of what's going on in there. What kind of container is it? What does a liquid look like? What does the gas look like? What are the readings of all your detectors? And the second is to go and get a sample, if possible, and bring it back to that safe part of the hot zone that we talked about, usually right beside the decon area. The only time you're not going to follow this initial recce procedure is when you've got a suspected white powder call. You're not going to go in and sniff around with detectors when you've got a suspected anthrax. In that case, you're going to jump directly to section 5, or at least section 5 in version 1.1 of the protocol, which is our white powder protocol. The equipment you take in is pretty much going to be the same every time. It's all the low-hanging fruit stuff, and it's all the stuff to keep you safe. This is the initial recce sheet. It's pretty much the same for solids and liquids and gases, because the initial report of what you had, it's a leaking gas, it's a liquid, it's a spilled solid, that may be incorrect. So you basically send guys into the hot zone, and they don't come out until they have these numbers, even if those numbers are 0, because 0 values are actually really important as well. The first items on this checklist, and all this assumes, of course, that you know how to use these detectors. If you don't know how to use these detectors, and you don't know these procedures, you shouldn't be doing this. So we're going to skim over it pretty quick. I'm using a contamination meter and a survey meter for radiation. It's not because radiation is super common, or radiation calls are super common. They're not, but it's an easy thing to rule out. And if you make a mistake on this and you're actually going into a really hot source, there's no PPE in the world that will protect you against a super strong gamma source. So you're going to go in, if your contamination meter is reading over 300 counts per minute, CPM, or your survey meter is over 5 microsieverts per hour, that's 5 USV per hour, you back off. You've got a radiation call, now you're going to establish your radiation zonings. It was good. You found out what you needed to find out. The next detector that you're going to be using is your PID. In our case, it's a PID, it's a 5 gas, so it does oxygen, LEL, hydrogen sulfide, carbon monoxide, and VOCs. Now keep in mind that the PID that we have has a 10.6 electron volt length, which means it picks up some, but not all of the organic compounds. In general, it'll pick up the medium to long chain hydrocarbons, and the short chain hydrocarbons like methane or ethane or acetylene, those short ones, it may not pick up. As you see, we've attached a pH strip to the tip. You can wet that strip if you want, works a bit better, you don't really need to. So you're going in with all your equipment, but you're watching the pH strip. If that changes color, especially if it turns red, but also if it changes in any color change, at that point you've got a decision to make. Do I turn off the PID? Because an extremely corrosive gas will rot out the interior of the PID. So if it's a nothing call, and this thing turns bright red, you might want to turn off your PID just by holding down the on-off button. Assuming this doesn't change color, you're going to go in and you're going to get readings for those 5 values. Write those 5 values down. Write down your LEL, and if it's bigger than 10%, get out. Because that's what the law says. Write down your oxygen. If the oxygen is under 10%, you can't trust your LEL readings. Again, then you got to make a judgment call. Write down your CO, write down your H2S, and write down your VOCs in the correct units. The next item we're going to have that we're taking in is our chemical warfare agent detector. In our case, it's an LCD 3000. We might be using other stuff in the future, it's hard to say. Most of these detectors not only do they detect chemical weapons, but they also detect toxic industrial chemicals. They've usually got a list. You've got to check the documentation to see what's on that list. And if it encounters one of those industrial chemicals, not a chemical warfare agent, but an industrial chemical, it'll go into alarm. It may or may not tell you what that chemical is, but at least it'll narrow it down. Yes, there actually is something here, and it could be one of these 20 chemicals. It's good information to have. If we're going in, we might as well have our PAC 7000s with us. These are little single gas detectors. And as we talked about earlier, if we're getting a hit on the chlorine detector, positive or negative, that can tell us something. it can tell us that we've got chlorine or something else that's cross-sensitive, that this detector is cross-sensitive to. Write down all those values, including if that value is 0. So you're going to write down a number for chlorine ppm, a number for ammonia ppm, a number for hydrogen cyanide ppm, a number for sulfur dioxide, and a number for phosphine. Finally, there's some information about the physical state of that product. Is it a solid? Yes or no. Is it a liquid? Yes or no. Is it a gas? If it's a solid, is it a block? Is it a chunk? Is it crystals? Is it a powder? If it's a liquid, what does it look like? Does it look like oil or honey or water? Or does it float on water? Does it go to the bottom of the water column, if you can tell? If it's a gas, can you tell if it's lighter than air, heavier than air, and what color it is? All these are really important clues in the big game of finding out what this chemical is. And finally, you're going to try and take a sample of this. You've got to be extremely careful if these are crystals, because we could have an explosive crystal like picric acid or TATP. So you're not going to, for example, open a jar that's got crystals around the rim, because that friction of opening the jar could set off the explosion. But if it's a liquid, or if it's loose powder that's clearly already been disturbed, and you're not going to do any more harm by scooping up a little bit of it, you're going to take that in your sample kit and exit the hot zone once you have all those numbers. Now, how do you carry all this stuff? That depends. Sometimes we've carried them in a bucket. Sometimes we've put it on a dolly and pulled the dolly in. Sometimes we put all these detectors on a lanyard. So you got a bundle of, a cluster of detectors hanging off your hip here. And if one of them goes into alarm, well, then you gotta look through them and try and figure out which it is. And when it comes time to write down the number, one guy's reading off the numbers, the other guy's writing them down. How you actually take all this stuff into the hot zone is up to you. It's dependent on the physical environment in which you're operating. So once you've collected all your data, you've got your signs and symptoms, you've done your entire initial recce, now it's time to decide whether to go on. Do you want to go to the next level of identification, or do you have enough information to wrap this call up? If you need to go on, if it's a solid, you go on to the next module in the solid sequence. If it's a liquid, you go on to the next module in the liquid sequence. Same for gas, you go on to the next module of the gas sequence. There are some similarities, but here's where it begins to diverge. You've done the same thing, regardless of the call, for the first 2 steps. Step 3 and onward, that's where things start getting specialized for the physical state of the product that you're dealing with.